to host Professor Alessia Damonte for a lecture on types of causality or causation, actionable pluralism. Let me suggest or present Alessia, and also thank you for coming.
Thank you for having me.
Our pleasure. She's a professor at the University of Milan at the Department of Social and Political Science. Teaches courses on policy design evaluation, contributing to new computational models and design app, and sits on the Open Science University Commission at Milan. She is also one of the founding members of the SISP Standing Group on Research Method for Political Sciences,
yes.
and as well as political science and public policy, involved in the ECPR Standing Group on Regulation and Governance. She is interested in the quality of procedures for public policy design. This is at the policy level, but also on method and methodological pluralism. Thank you very much, Alessia, and the floor is yours. We are happy to have you in Jerusalem.
Thank you. Thank you so much.
Please.
And thank you for being here. And this is what I'm going to present actually is part of, shameless self-promotion, part of a book that we developed together with a lot of nice persons around the world on the different ways of getting causation, and getting causation, or at least getting causation so that we can make use of them in public policy and related disciplines or related fields. The point of this contribution and this talk is, okay, let me just pass through, sorry, I'm bombing. Let me pass through the points. I will first introduce the motivation of this talk, then the different approaches in causal analysis, and then I will try to table the question, or try to find whether, a response to the question whether these approaches in causal analysis are complementary or incommensurable. And in the end, I will try to sketch some common ground on which possible complementarity can be developed among different approaches to causal analysis. But let me start from the motivation first. There has long been a call in causal analysis and causal studies to perform multi-method design. The point was that multi-method design, so mixing method, quality, and so on and so forth, may not produce better results than using a single research strategy alone. The point was that you may not compensate for a weakness with the weakness of another strategy. And so the call came, and very loud, from Harry Brady, who said if you are going to develop a multi-method design, especially concerned with causal analysis, you might have qualitative or quantitative components, but both must separately meet the standards for persuasive inference. And the point, okay, it makes a lot of sense, unless you think that, and this is Kuhn recalling us, that actually different approaches may be really different paradigms about the world, and develop in different languages. So how can you make multi-method design by using techniques that may refer to completely different worlds? And this is the issue. And this is the question, whether they are really at least compatible or not. So first, what are these approaches? In order to assess the question whether they are complementary or incommensurable, let's try to introduce what are the main approaches that at least everybody recognized. We may expand part of them. But these approaches start from approaches to causal analysis, start from regularity. This is law-like causation. Quest for law-like robust relationships covering single cases. The basic reasoning is that there are two dimensions. There are questions about singular causation in the case and question about generalization. So causal connections that hold beyond the single case. And basically you need both, but it's hard to keep them together. And in regularity, the issue was that you can claim that a single token, so an actual cause, a cause in the single case, is causal, and is causal of another token y if if you can generalize, so if you can find similar objects to x, and so build a class, generalize, build other objects similar to y, so build the class of objects y, and then find that across all these similar objects, whenever x, then y. Whenever x is present, y is also present. So the warrant of this regularity was the fact that x can be considered, or has to be chosen among the regular space-time antecedent to y. What you gain from this? First, you gain the fact that you can try to infer causation from observational data, which is not banal at all. And basically, you can reject that the relationship is accidental. If you see the same pattern, there should be something beyond. But regularity is plagued by a lot of issues. The relationship that you can mistake for causal something that is not causal, so it can be X can be spurious. The true cause can be a compound, and therefore you may not identify it by looking for laws. The causal factor can meet hindering factors in the field, so you may throw away your cause just because in the light of omitted factors that hindered the consequent, that suffocated the consequent, and so those missing the criterion, failing the criterion. Moreover, regularity can be based on misclassified or cherry-picked evidence, and therefore you cannot believe regularity. You cannot believe causation on the base of regularity. The second solution then was counterfactual. Counterfactual is again a strategy to establish causation in singular cases in the original version. And the reasoning is if you have a token x that is, if token x is cause of token y, then in the current world, you should observe regularity against a background. And it should also happen that by maintaining the same background constant, in a twin world, the removal of x should also lead necessarily to the removal of y. In this counterfactual thinking, counterfactual single case design and thought experiments, mostly. We have a rich literature of that. The warrant for the claim that X is causal is the fact that you can imagine, of course, that the removal changes, so that X is some kind of a switch that can change the state of the outcome that you are controlling. And the fact that you can claim that X is a switch is because you maintain the background constant. So it's the background that provides the warrant to the whole operation. It has the advantage of applying to rare events, which of course regularity cannot. Components of causal compound can pass the test. If you have an element that can make fail a big compound, then by switching the state of the element, you can change the state of the outcome. And moreover, there are spurious causal factors that may fail the test. So the barometer can never be a counterfactual cause of a storm, even by through counterfactual thinking and by imagining a counterfactual world. What are the issues, however? First, the claim that the background is the same as, and even in mind experiment, has been contested. It has been contested that the operation can be so naive. If you have to think of the same case without X, you have to think to removing the original causes of X in the world, which requires a far wider, broader intervention than the one that the experimental mindset would require. And this is a criticism that resurfaces across different approaches. And therefore, the point of keeping this constant background basically can be boiled down to two elements. First, that there can be alternative causes Z that operate in the background, or that the background may not be so easily kept the same. This is especially true if you want to find the exact match, or if you want to build your exact match, even in synthetic control, that may work in almost a similar way. You may want to question yourself whether you have operationalized the background properly to ensure the constant or the ceteris paribus effect. Now, the evolution of the counterfactual is manipulation. Manipulation is counterfactual that tries to bypass the problem of the background, of the common background, by going to it at the population level. So the fundamental idea is, in this case, that the cause is still a switch. The idea is finding a cause that is still a switch, so something that is able to change the state of the outcome, of one outcome. The point is that it happens by comparing collective, and by comparing collective that are purposefully built. So the reasoning beyond manipulation that can be, I mean, it's the rationale of randomized controlled trials, for instance, or mostly, but not only. There are a lot of different designs that perform the same, or that follow the same rationale. But the reasoning, the underlying reasoning is that if you have a treatment, in this case, so you manipulate, you control the cause, the treatment is a cause of an outcome, Y, or generates an effect. If the average treatment effect, the expected difference between the outcome, the positive and the negative outcome, is equal to the expected difference of the two outcomes under the condition of the treatment being present, plus the expected difference in the two outcomes under the condition that the treatment is absent. And these two expectations are, moreover, weighted by the proportion of the cases that are treated and non-treated. This is one of the versions, straightforward version of the average treatment effect. And if you find that this is not null, and this is something that you can calculate by observing and by constructing similar or almost twin populations, and by comparing the results, the effect of the treatment against the control group, you might, of course, observe this otherwise impossible difference, the difference between the treated and the not treated being the subject the same. The warrant is that the units, so how can we perform this special operation? How can we bypass the fundamental problem of causal inference, comparing ourselves in two different states, one with the treatment and the other without? The warrant has always been said to be the randomization. If you randomize from a population and so if you randomize the member of the units that enter the control group and the treatment group, and you randomize it from a population, then you may ensure that the biases are null from unobserved pre-treatment factors. So there is no, or at least you may reduce the effect of the so-called self-selection, the fact that there may be, let's say, different Z or different alternative causes that are widespread differently in the control group and in the treatment group, or different compound, different reactions, different way to achieve the same outcome, other than the fact of treating somebody. Just because you might have people that do not react to the treatment and people that would have displayed the outcome without the treatment. So these are two kind and a heterogeneity in the population that you select that may affect the difference between the two groups. Randomization is supposed to keep at bay this difference, but you may never be sure of it. You may never be sure, and there may be a lot of issues or a lot of things that may not be, that may go wrong. The treatment may not be independent of the outcome. The randomization may not be really able to rule out a heterogeneity effect. And one of the interesting things is that manipulation in this version, in this experimental version, has always been considered or presented as the golden standard of causal analysis. And the point is, it has been proposed as or claimed to be the golden standard because the idea was you can identify a cause even without knowing the reason why the treatment can produce the outcome, can produce the effect. Why it is causal, you may not know, but evidence tells you that there is a causal effect. So it's a way of measuring causality. Doesn't require any special theory about why the treatment succeeds. But the point is that each and every, and those are just a selected part of the criticism that can be raised toward, or the warnings that can be raised toward manipulation strategies. The point is that these limits actually are related to exactly to the fact that you may not have a theory about why your condition is, your treatment is working. And you don't know, therefore, the heterogeneity, where the heterogeneity can come from. And therefore, you may or may not be fully able to control for heterogeneity.
But this is true also for the regularization mechanisms or... Yes,
if you want... yes, in this case, yes, you know, it can be spurious. In manipulation, you don't have spurious, the issue, possibly you don't have spurious factors. You have ruled out the spurious factor. You still have the possibility of having alternative causes that work in the background. So you treat your control group and you think you have a wonderful effect. The point is that for whatever reason, you may have selected a person that already displayed the effect. So the effect is not the result of the treatment. The effect is the result of some heterogeneous cause that is working in the background and you haven't accounted for. And that, for whatever reason, is overrepresented in your, yes, in one group instead of another. So the difference doesn't discount it.
If you speak about counterfactuals, do you need to have a theory? Also not.
You need to have a theory, yes, because one of the examples for counterfactuals, would JFK be alive had Oswald been stopped? You must have a theory about how JFK was killed. Because what is that you control, what is that you remove, and what are the conditions in the background that would still be there.
But even the design of, say, manipulation, it should be driven by theory. It might be wrong or not, but it's theoretical selection.
You are already pluralist. Because the fundamental idea, okay, the issue in going for manipulation is you don't have a clear theory. But you need to know whether this treatment makes a difference or not. Okay, it's a shallow theory. And the point, no theory, because theory may. The idea was a theory. In these quarters, theory can be something I wouldn't say biasing. Okay. If you believe in a theory, you may be induced to select in a certain way. So you are introducing a bias into your design. While being skeptical, even if you have a theory, being skeptical and designing your control and treatment groups as blind as possible would improve the credibility of your results. Point is, can you really leave your theory aside, or can you really not? Or then you may be concerned by the fact that in these cases you seldom see the issue of further special conditions entering from the background. You always have techniques for making results robust. Making results robust means making the results as much as independent from the background as possible. Reducing the background to noise, making it independent. Then the issue is, but what if it's not really independent? So independency is a statistical artifact that you have built with your wonderful and apt designs. The question is always there. And the point is, of course, if you start questioning the background and the relationships, you end up with mechanisms. And mechanisms in Brady, so Brady presentation ends up with mechanism as if mechanism could be some evolution of previous. And actually, it is a, let's say, can make other approaches, can accompany and can enrich other approaches. And it has been done, actually. But if you, the idea is if you get a mechanism, you start thinking in terms of dependence. This is Pearl, but it is also path analysis, so this is just conflating different approaches around this intuition that in order to a certain causation, you need more than two terms. It's not just X and Y, you need X, Y, and something else, Z, okay? And you may question the relationship between Z, X, and Y. And you might have X as a cause when it's a mediator or when it moderates another relationship and you don't know whether Z is actually the last in the chain, the origin, or whatever. But you know that X can moderate a relationship or X can mediate a relationship, and then you may recognize a causal role to X. And there are instead structures where X is not causal, and or at least where the statistical recognition of X can be trickier, or the statistical operation on X can be trickier. The confounder is the classical structure of a spurious relationship, and of course the point is that you might see a relationship between X and Y within I don't know, ice cream and rates of crime, rates of ice cream sales and rates of crime or whatever, people drawing and Nicolas Cage films cast. Because it's confounded by another factor. So the relationship is statistically present, but if you control for Z, then the relationship disappears. And this is the classical thing that you do when you want to you slice your samples and you try to verify whether by controlling by Z, by another factor, the relationship remains significant or not. The point is, and this is, it has been added by Pearl, and it has been circulated. This is a very different or specularly similar relationship. In this case, X is the alternative and alternative in the sense mutually exclusive cause of Z. And why is it relevant? Because those two may look independent until you control for Z. When you control for Z, suddenly you see a flow of relationship that you may mistake for causal flowing between X and Y. And the point is, the point of adding a collider together, discussing colliders together with confounder, is that if you think that your solution to checking for causation by controlling for whatever Z you think it's relevant may end up making up relationships, significant relationships, because you didn't know that Z was your collider. Instead, you thought that Z was your confounder. So again, you need a theory, and you need a theory also about the directionality of the relationship. You have to try to test, to check. So fundamentally, in this world, you have, at least this path analysis, you have an elaboration of regularity, for instance, empowered with or supported with theories about structural relationships. Okay. Moreover, you can go further because Pearl actually didn't stop at the level of developing structures, but also trying to imagining interventions and by calculating what would happen to the relationships if one of the link were erased. And this is what do calculus can do for you. Okay, simulating the independence of single factors to treat them as they were treatments in manipulative contexts. So at the end, you can get experimental results with observational data by going this way and by developing this path analysis, do calculus, and constructing or designing on observational data quasi-experimental design. You can have almost the same findings, although non-parametric in a non-parametric way, than you had in experimental context. And moreover, given that you might have data on whole population, big data on whole population, this kind of path analysis could be quite interesting and useful. What is the issue? The issue is that the model specification remains untested. So why are you selecting T, Z, X, Z, and Y? So you have another way of understanding mechanism, that is mechanism 2. Mechanism 2 is a way of modeling heterogeneity. This is qualitative comparative analysis, basically. This is, the idea is that you have a token, and causality is not associated to a single factor, is associated to a compound. So the quest is for identifying the elements that compose the compound, and this is so-called Ainus causation. So every factor is an insufficient but necessary part of an unnecessary but sufficient compound.
You're
Yep.
bring Charles Regan's idea of conjectural causality. Is it
Conjunctural, equifinal? Yes, of course.
This is here.
Yes, it is this one, sure. But played in a certain way, that is to say, if you should, in order to claim that you have the solution, you might still want to have a counterfactual reasoning beyond. Thus meaning that you might claim that X is a partial cause of Y if X is part of an Ainus, is an Ainus condition of type, an Ainus condition of type C leading to Y. And the warrant is that the same pool of candidate Ainus factors should be able to account for the presence and the absence of the outcome, albeit in different combination. So the idea is that with the same pool of factor, you should be able to account for the presence of the outcome. For instance, the presence of A and the presence of X build a compound psi1 that leads to the outcome. But X and the presence of X and presence of B build a compound psi2 that is still a solution, an explanation, that can account for Y. So the solution to Y is psi1 or psi2. Should cover different cases and so on. The same factors run with the technique of a qualitative comparative analysis may let survive not X as the only factor explaining not Y, and construing the Ainus compound psi3. So in this population, it may happen, or it happened, and you may have the logical proof that psi3 is the negation of psi1 and or psi2. And together account for all the positive and all the negative. What does it mean? It means that actually you have the sufficiency distributions for the positive and for the negative. So the same cases should be distributed in this upper triangular shape, that is the shape of sufficiency. by psi 3 if you are distributing the cases, the negative cases, so the cases with the negative outcome, and should still keep maintains or enter in the same shape if the same cases are distributed by the solution to y against the outcome y. So the shape, the cases are the same, the shape should be the same, but the solutions are different from the same pool of factors.
And the misspecified are
the misspecified is a further information that you can get when your model, so your cases do not fit perfectly the sufficiency, the shape of sufficiency. If you get cases here or cases here, you have a hint that your model is misspecified. That was the quest. How can we know that we have everything relevant in our models? Well, we may run some kind of specification. It can also, there is an overlapping with the random forest, for instance, albeit. It should be further tested. Nevertheless, the issue is you may end up with factors addressing the quest for what is relevant to account for y and to account for the absence of y, so that you may use this information in other techniques or and the misspecification is simply a warning that your model, the conditions that you have taken into account are not enough. So, of course, there are limits. For instance, the dichotomization, given that this technique is based on dichotomization may or may not prove idiosyncratic, at least connected to the cases that you have at hand. So this is, again, an issue of measurement that questions may lead to questioning the results. And another point that has been developed is that has been raised is that you may specify your model, you may have your wonderful paths. The point is, in single cases, you may have a lot of different processes running. So how can you know that those are really the specific, or the problem of causal process heterogeneity and not just of heterogeneity. So we have the third version of mechanism. The third version of mechanism is Beach and Pedersen, Collier, Bennett, Van Evera, the process tracing mechanism as process tracing, and is the idea that you can establish causation. At least you can claim that there is a causal connection if you can trace the connection between x and y. And of course, by tracing this connection can have a discovery side, but there is also, or maybe, and this is again an issue, but I would say that it would be hard to provide process tracing otherwise, or to trace processes otherwise. You may need, again, a theory about what what connects x to y, at least a theory that can be disconfirmed. But the fundamental idea is that you go and you trace your process by looking, by expecting some fingerprints, and then by looking for those fingerprints into the single cases. So the manifestations of your process and, of your causal mechanism as your process. The ascription of the case, at the end, you may ascribe your case to your theory because you have traced your process within the case. And the ascription works to the point that, or as far as the traces can be unique and certain evidence of the causal process, which may not be always the case. The advantage, of course, is again, you can operate on real events, you can cast light on diffusing factors, having better knowledge of how the mechanism, how the process unfolds in the case. Still, issues beyond, of course, that of available evidence is that you may you need, in order to improve or to strengthen the tracing of your causal mechanism, you may want alternative mechanisms or alternative theories, alternative processes, so that you may want to rule out, to establish, to ascribe your case to one of the hypotheses, clearly. And the point is, you may be omitting hypotheses. So you may be claiming that your case is a case of a certain process just because you didn't consider the possibility that other processes were at work in the case. The last issue is that you may develop your induction, you may develop your inference on traces and knowledge and pictures of the process that are so idiosyncratic that the knowledge cannot travel. So if it's just a model that explains Milan, it may not be that useful. So you need to generalize, but to generalize means that you have to build the great famous classes of similar objects. Without similar construction, this kind of similarities in measurement, you may not be able to make your knowledge travel. So the point is, are those elements, so the different approaches, complementary or incommensurable? Let's say that the assessment can be done at 3 different levels, of course, ontology, epistemology, and methodology. At the level of ontology, the question is, what are the ultimate objects in causal accounts? Of course, some have laws of regularity, patterns. Others have counterfactuals, that is to say, the switches. But none of these are causal objects. Laws is not the response to the question why something. It's that something happens regularly. Okay. Counterfactuals can get to the why, just because this changed. But the switch operated. Point is, it's not a causal object. It's a criteria to identify a causal object. So in the end, what we are left with are mechanisms as possible ultimate objects in a causal account. There are a lot of advantages in using mechanism or establishing mechanisms as the ultimate objects in causal accounts. First, they can evade infinite regress and circularity laws because there is a pattern. Okay, but why there is a pattern? Because there is a pattern at the lower level, So laws may open up the Pandora box of infinite regress. Mechanism can prevent the reduction of causality to non-causal objects or methodological criteria. They also can lend credibility and make sense of laws and counterfactuals. So a mechanism can support, and we have seen with Pearl, they can support a regularity claim and counterfactual claims. So they are good candidates for a fundamental ontology, at least for those who make causal analysis in the social sciences. We have an issue. Mechanism may afford too many definitions. There are Inus compounds or mediating or moderating factors or within case chain of activities. And the issue is, are these different words? So it's just a redefinition of a problem, in other words. And the response may be not. Mechanism can have a single unifying ontology beyond that runs from Russell to Reichenbach to Solomon and Doe, and that understands causality as a single object from two perspectives. Causality is the seamless persistence of something. Causality is the seamless transmission of a non-null conserved quantity. So it's the process, the flow, okay? It's the causal rope. It unfolds across space and time, and it happens between two alterations. And those alterations occur at intersections of what? Of causal quantities. So alterations are important, and intersections are important in the definition of causality, because it's the only way through which, yes, we can separate non-causal quantities from causal quantities. Non-causal quantities pass through intersection without modification. Causal quantities instead are modified in intersection. And Reichenbach and then Solomon identifies three kinds of intersections. The lambda intersection, the gamma intersections, and the chi intersections. The first is the single quantity splitting into two. Then you have the joint production. And then you have the chi intersection, that is the chain transmission of quantities. 1956, more or less. And further, up to 1990s. So in this way, those are really complements. Okay, then there are different manifestations. But at the point, there is, causality is persistent with changes at the beginning and the end. Now, epistemology. How can we know causation then? And here will you find the foundationalist and the naturalist. The foundationalist ask how we should know causation. And naturalist how it happens that we know causation. So the first apply rules and standards, and the second investigate social beliefs. And those may be quite different. Are these relevant to our story? Yes, they are, just because these perspectives emphasize or are present in different understanding of probabilities. This is something that is usually underestimated in the analysis of the approaches, but actually is fundamental. And this is where the languages, the Babel Tower arise. Because probabilities can be in the world or in the mind. If they are in the world, you may think of them in terms of frequencies, and then you have the collectives. Or you have the propensity, and which refer to individuals, but you must have a theory about the individuals and the factors that make this individual increase the propensity to show, to risk, to show a certain situation, to enter a certain situation, and so on and so forth. If you think instead that it's in the mind, you may distinguish, because you might have the logical and the subjective. The logical is the rational belief that, or the belief that the rational mind would entertain about the relationship between propositions, given evidence. And this is something that you may find, again, in For instance, the Bayesian analysis of processes or the Bayesian analysis of dependencies, path analysis, or QCA. And the subjective again, is the degree of credence or expectations of an event as a betting quotient that doesn't need to be plausible or rational at all. It's just, it has to amount to 1. And the subjective is, for instance, something that is very considered or emphasized in some analysis of process stressing. So very often, there are games that are played with these different languages, and they may not speak to each other because the assumptions or what is the finding is different, the sense of the finding is different. Albeit they may be possibly complement if you consider that we may have subjective, entertain subjective probabilities that may not prove rational, that may not fit the distribution, that may or may not influence or entertain some relationship with propensity, define propensity. So it very much depends on your object. But still, this is source of misunderstanding and quite that deserves some attention. So if those are possible complements, so we have an ontology that may be complemented, an epistemology that where different languages may cast different light to the same on the same object, but still be together. The point is, okay, so where is that we don't find enough common ground? Methodology. And again, I have selected this that is quite consolidated as an approach. That has also been contested in of course, the content has been contested. It is long time has passed. But the system of logic provides an interesting viewpoint on these two alternatives that, according to some approaches, any social scientist has to take a position. You may a certain causation based on design or based on models. Okay. If you based on design, you are in the manipulation, theory-free or as free as possible world. If you are in model-based solution, you bring in your theory, but you may be slave of your biases, definitely. So this is the usual, and the design-based, again, also they follow the ontology. You may ascertain causal relationships by operating on the factors, the background, and the two factors of interest. So you have X, Y, and the background. The point is you might keep the background still and allow the factors variate, or you can keep the factors varying while keeping the background fixed. So one of the elements of interest in this proposal is that the relationships, the the relationships, even regularity, is considered as a design-based analysis or as a design-based finding. You can believe a regularity if everything, the factors are constant or the pattern is the same across very different cases. Whereas the experimental is the trick and the need is to keep the background constant while making the condition, the two factors of interest covary, or allowing the two factors of interest to vary. And those are basically you may be quite aware of, and you may know the content of these different designs, but basically those are all variations on these two themes. Factor constant against a varying background, or varying factors against a constant background. And the need for going toward model-based solutions is that the threats to the designs are generated by the fact that causes can be, and so on theoretical, ontological, in that case, causes can be plural or composite. Plural means that X and the two colliders, X and Y, may be generating together as alternatives or jointly given can generate the outcome. Alternative or composite, that means jointly given, or as physical transmission. So the composition may also have two different shapes. The physical, that is the pool, the pool balls, and the chemical composition, that is chemical emergence, that is the chemical reaction. So those are two different types of kinds of composition of causes. And from these plurality and composition of causes, you have the threats to the design-based solutions. So fundamentally, those are, once again, complements. So at the end, what you get is, if you think that the mechanisms are the fundamental, or let's say that can provide the common ground, and in the mechanism, what can really be of relevance, whatever strategy of a certain causation you may want to go, if you think that, what you find is a list of possible causal structures that you may understand as paths, as compounds, so you may render with different languages, you may render for different techniques, but in the end you find them not just in Reichenbach and Salmon, those are the first three, chi, gamma, and lambda. But you find them in Mill as composition, physical, chemical, and plurality. Then you have this, the spuriousness is just a fact of causation and therefore is not listed. The Reichenbach and Solomon may not be recognizing the disjoint production, that is the collider for Pearl. Pearl may not be recognizing the joint production, only has disjoint or the common cause or the chi transmission. So it's not that each and every typology covers the very same, but they have been developed to respond to different kind of quest. Pearl is developing an informational theory of causation, of influence. Mill was for, yes, developing and establishing causation as such. Reichenbach and Solomon were on an ontological and philosophical level, so less concerned with the methodological maybe, or design issues. And here we have Kendall and Lazarsfeld that is usually not reported, but it is quite interesting and quite old, of course, developed in a book edited by Merton on the American soldier. They developed these ways of what? Of making correlations speak. Okay, so you find a correlation, then can you take it for certain or for true? Of course not. Then what you may want to do is to add a further factor, and if it's a mediator, then it provides an interpretation of your correlation. If you you may specify your correlation. You can explain it away. If you find your Z, then you get your cause, of course. Or you may specify the outcome when you have disjoint production. So those are the typologies, as far as I know, the typologies that have been developed to make sense of causation. And the interesting element is that they are extremely overlapping. So either we lack fantasy, or they really are the useful structures on which one can build. And the hope is that starting from, if we work on these, regardless of our strategy, language, identification of idea of probability or whatever, we may speak to each other and we may enrich our models. And that's it.
Thank you very much.
Thank you.
So just a few words. You took us far, far away, maybe more than we are ready to be taken, because it was rich presentation, very demanding, and I'd like to thank you for this.
Thank you for.
I'll allow for 2 questions because we are over time. So, please.
No universal recipe for sure. Of course. What I find useful is start from your why. Start from what you want to explain, and then go in any direction backward and try. Sometimes you may be drawing in literature far from yours, but you may learn a lot even from those far literatures, because especially if you think that they contribute to something, so they may be pointing to some factor that may be causal, or may be somehow part of your explanation. And the point is that if you find this explanation may be robust, so may really travel, may really provide a good way to intervene and to account for, or also to reproduce helpful outcomes, useful outcomes.
I like the idea that focus on your dependent variable, because I think many people are assuming it away and focusing on the causality. So know what is the thing that you want to explain, and work on it, and think on it, and conceptualize it, see its border before you go to the
all those kind of analysis. Phil, you don't have to.
Small question, only in the beginning of my path, is that every time that I look at causal structures, it always look very neat, very simple. It's like, and every time that I start a project or research, I think that I need to aspire to this direction. And then after a few months, I found myself in a sort of a chaos, and maybe is there a way to use, what are your tips of a way to use it, also the structure, so what you showed here, to also to plan better and to clean up the mess during the research.
That would be, I would be happy if I could help you actually to develop and not to get lost in your literature and in your project. I know that this is a feeling that we all share. Sometimes knowing where you want to go is, even if it's just a sketch. So yes, definitely.
So assume ontology of complex for world and walk your way via simplification, but not too much simplification. This is my interpretation. And the final question is, what is causality? Can you define causality? Is it? Can you give nominal definition, or you prefer to avoid?
No, I prefer to
avoid. So nominal causality definition and so on in the next research.
Okay.
Thank you very much, Alessia.
Thank you so
for
much for